Hi friends, in this video let us see what is meant by impulse response and how this will be useful for convolution and convolution sum and convolution integral. So that will be covered in the next video, and this video is for particularly for impulse response only. Let us see what is meant by an impulse response. Yeah, actually impulse response means it is the superposition of time shifted impulses. That means any signal can be represented as superposition of time shifted impulses. Okay, that will be seen clearly here. Let us consider a signal x of n, of course that is discrete in nature, so that will be multiplied by impulse response delta n. That will be like this. So x of n into delta n, as we know delta n is an impulse signal, so that will be delta n means it is having value 1. For example, it's a unit impulse signal, its value is 1 at n equal to 0. Its value is 1 at n equal to 0 and all remaining values are 0. Let me take x of n has some signal from minus infinity to infinity. It is having some different values. But when multiplying with impulse response, what will happen? Yes, impulse has 0 value other than at n equal to 0. All values of x of n into delta n will be 0 except at n equal to 0. So in x, that can be exactly equal to x of 0 delta n, that's all. Okay, only the value of x of n at n equal to 0 will be remaining if you multiply any signal with delta n. Okay, that is the main concept of this, so that we can have time shifted impulses for various things. That will be explained now. So if you can understand this part very clearly, then we can move forward and so that how we can represent complete x of n. So this relation may be generalized to the product of x of n and time shifted impulse responses. So how can we do this? So by using this, I can say that I can get x of n at n equal to 0. Now how can I get x of n at n equal to 1? How can I get x of n at n equal to 2? How can I get x of n at n equal to 3, and so on to infinity from minus infinity. So this is my concept. So now that will be shown as time shifted impulse responses. So please see this. Yeah, so this is a time shifted impulse response. So generalized term. For example, I want to know the x of n value at n equal to k. How can I do that? For that, I can multiply x of n with delta applying at n equal to k. So that will be delta n minus k. Okay, if that is the case, that will be converted into x of k delta n minus k simply. Okay, so this is the concept here. So for express x of n as weighted sum of time shifted impulses. So that can be easily dealt here. See, now x of n can be explained like this. It is from minus infinity to plus infinity. So I am starting from minus infinity and I like to represent at n equal to minus 2. So x of minus 2 delta n plus 2. So if you can see here, x of k delta n minus 2. Okay, here k equal to minus 2. So x of minus 2 delta n plus 2 plus x of minus 1 delta n plus 1 plus x of 0 delta n plus x of 1 delta n minus 1. If you can see here, this is n k equal to 2, x of 2 delta n minus 2 simply, plus and so on. So in this way we need to represent each and every value when multiplying with impulse response at that value only. Okay, so this is the concept of impulse response. So finally we can represent by using the sigma x of n is equal to sigma k equal to minus infinity to infinity x of k delta n minus k. So So this is the final expression of impulse response. So let me see with an example. If this is an example, so this is my x of n. The value of x of n at n equal to -1 is maybe minus 0.5, and at n equal to 0 is +1, and at n equal to 1 is plus 0.5, for example. How can I retrieve this? By using impulse response. Yeah, this is the formula. X of n c is equal to sigma k equal to -infinity to +infinity x of k delta n minus k. So with this formula, yeah, I can represent, actually I have x of my first value from -infinity to +infinity. I like to see the values. So the first non-zero value is at n equal to -1. So that was shown here clearly, and that will be multiplied with, this is at k equal to -1 now. So this will be multiplied with delta n minus k. Okay, so it will be delta n plus 1 now, and this will be 1. Okay, as this is unit impulse function, so it has 1 here. Now these two will be multiplied, and finally I will get the result. So this is minus 0.5 and this is 1. So if I multiply these two, I will get minus 0.5. Okay, same thing. So now I am able to represent one value at n equal to -1 by this formula. By using this formula, this is x of -1 delta n plus 1 by using multiple of impulse response. Yeah, this is for the second value at n equal to 0, and this will be multiplied with unit impulse response at n equal to 0. So if I multiply these two, I will get this value. So same value will come. Similarly, at the third value, simply I can multiply with delta n minus 1. So application of impulse response at that value. So here the value is 1, k equal to 1. So I got this value. So if I add these things, plus and plus, that will be equal to original signal. So this is the exact concept of impulse response. Okay, so what we need to do, we can represent our signal as the superposition of multiple of the value at that k and impulse response applied at that k. Okay, very simple concept. So this is the explanation regarding impulse response. And thank you so much. If you like this video, please like it and please share with your friends and family. And if you haven't subscribed to my YouTube channel, please do subscribe and kindly press the bell button so that you will get the notifications. I like to complete the signals and systems within 1 or 2 months only. So please try to follow so that you will get the complete knowledge out of it. And if you have any doubts, please write in the comment box so that I can reply at the comment box only. And if I commit any mistake, please do mention in comment box so that I can change myself and I can become better in the next video. So thank you so much.